Okay, I'm back now. I make a little bit of mistake here. So my x should be 0, my x should be 2, and then 4 over 7. And here it should be negative 2 over 3. Okay, not 3 over 2. Right? I made a little bit of mistake. And then when I check for the answers, I check for the correct answers. I found that 0 is okay if I put it there in the original equation. Right? 0 is okay. 2 is not okay. 4 over 7 is not okay. Oh, sorry, I'm a little bit sick there. Negative 2 over 3 is okay. So sum of solution would be like 0 added with negative 2/3. So the answer is negative 2/3. Okay. So we want to go to the next problem now. We're going to go to the next problem. Okay. So I have to delete it out. Delete this one out. Absolute inequalities. Okay. This problem was quite easy. So we want to find a solution set. If you see something like this, you just square them up on both sides. Right? You can just square them up on both sides. So it's going to look like this one, right? With the absolute, you square them up. And then 4, you also square them up and then move them to the same side. Because you want to have a difference of 2 squared, right? You want to have the term of front plus the back, right? Negative 2 plus 4 is plus 2. And multiply with the terms of front minus back. Okay, front minus back. Right? Minus x. I think it's not gonna be okay. So I have, and then minus 6 and less than 0. Right? All right. I'll feel that if I do it like this, it's gonna take a lot of time. Right? So this problem, if we square them up on both sides, it's gonna look like this. But if we use another property, you know, right? With absolute is less than 4. We can have, we can take absolute out. It's gonna look like this, x squared minus x minus 2. And it can be less than 4. And the other side is more than negative 4. If you still remember these properties, you know, when absolute is less than something, right? When you take absolute out, you put the positive value on the right and negative value on the left, something like this. Right? And now, you may want to work on it like this and this, you know, right? Group 1 and group 2. So you go like this, right? X squared, sorry, you want to write like this. Move negative 4 there, it's 0, less than x squared minus x. And negative 4 plus, no, negative 2 plus 4 is plus 2. Right? You can factorize them into something like this. What is that like? This is like 2 and 1, so minus 2 plus 1, right? And this one intersect with this group 2. It's like x squared minus x, and then minus 4, right? No, minus 6. It's not different, not much different, right? Not much different from that one. So it's x minus 3 and x plus 2 is in 0. So I feel like it's not much different, not much different. So you can use square on both sides or use a property. It's gonna look very similar. Okay, so now write the number line down. Right? this one, you get, what are those numbers? You can get 1, 2, 3, 4 numbers. So -2, you get number 2, right? 1 is, now I should go like this. 2 is here, and then -1 is there. This one is more than, so it's gonna be like plus, minus, and plus. Like this, more than it going out. No. I shouldn't join them. I should have, okay, 1, -1 and 2. Right? This one is -1 and 2. Oh, I'm sick now. Left it like this. Okay, -1 and 2, and then plus, minus, and plus. This one will just go out like this, and then this one I group 2. I use another line right here. All right, and this is going to be 3, and then -2. -2 is there. Then this is less than. There you go, plus, minus, and plus. Less than is there. Right, something like this. So intersect, you find it overlap of them. Find the overlap of them. And I'm going to use the space here to write the answers. So x is going to be from -2 to 1. And then union with from 2 to 3. Yeah. So it's going to look like this. Okay, so in exam, you can do square them up on both sides like this, or you can use the properties like this. So up to you. They will both have the same answers, but anyway, if you trying to square them up on both sides like this, make sure that you use the difference of 2 square, because if you don't use the difference of 2 square, you will expand this. You know, right? This is x to the power of 2, and you square them, it will be x to the power of 4 if you expand them out. So use the difference of 2 square if you want to go with this one. Okay. Okay. Next one, right? Next one, find solution set of this one again. But this problem normally, right? Normally we never cross multiply something like this to the inequalities. But here is fine because the absolute is always, you know, right? Absolute is non-negative. It's never negative. Okay. But you have to set a condition that, okay, even that absolute is, you know, right, most of the time like positive, but it can be 0. It can be 0 as well. We don't want it to be divided by 0. So before you cross multiply, okay, maybe you can just cross multiply it like this. You can go like this, x squared plus 2x minus 8, and more than x squared plus 7x plus 12. No problem, I just cross multiply. But anyway, you need to set a condition that this divider, right, x squared plus 7x plus 12, you don't want it to be equal to 0, because it's not okay to divide anything by 0 and then factorize to find the x. That is not okay, right? 12 is 4, 3, because you want to get 7, so it's plus and plus. So x is not equal to -3 and -4. Okay, this is your condition to, this is your condition, right? To make sure that you don't have your equations divided by 0. Okay, so now you come back to this one. Again, square them up on both sides. Square them up on both sides. And again, use a different 2 square. I think that I'm gonna move the left hand side to the right hand side. So I'm gonna have like big 0 there, and then I will have a term of sum, right? Multiplying with the term of difference. The term of sum x is like 2x squared, right? And then 7 and 2 is 9. 12 minus 8 is plus 4. Okay. I use different of 2 square, you know. This is my sum term, this is my different terms. Different, right? This one minus that, x squared minus x squared, gone. 7x minus 2 is 5x. And then 12 minus 8, it's going to be plus 20. I think that I'm going to factorize them. This one and here, divide by 5 to all of them, right? Divide by 5 to all of them. I'm gonna get like x plus 4. Here is like 2x. 4 will become like 4 and 1 like this, and then plus to all of them. This is x, right? I think I'm correct. Yeah, I think I'm correct now. Shift. Ah, okay. And if I look carefully at here, right? You see, right? I have x plus 4 and x plus 4. So they are the same, right? So you can just group them to something like this. X plus 4 squared. And remember, right? If you still remember, when you have like x plus 4 squared like this is of course, right? Not the negative, right? This is never negative, right? This is never negative. And then and your x, this is never negative. And can it be 0? This one can be 0 if your x is negative 4, right? It's gonna be 0. Anyway, you look at this one, right? You already said that your x is not gonna be negative 4. So this one is never negative. This one is never 0. This one is 100% positive. So this one looks like it's like positive something, positive real number. So you can just like divide this one out on both sides of the inequality. This one is gonna be like gone. This one is gonna be gone. You know, right? This one square. So you can just have like 0 less than 2x plus 1. Then you're gonna write move something, right? Move 1 there, it will be minus 1. Move 2 to divide, minus 1 over 2. So your x is gonna be less than negative 1 over 2. Okay, so time to give the answers. Time to give the answers. So your x is gonna be right from negative 1. No. It's gonna be from negative infinity. Right, negative infinity, and then stop at negative 4. Yep, union with from negative 4 to negative 3, and then union with negative 3 to negative 1 over 2, something like this, right? Or if you want to write like this, it's okay. Try negative infinity until negative 1 over 2, right? And take out the number that we don't want to get, which is negative 3 and negative 4. That's fine. Okay, so this problem is done at here. So next, it's going to be a function now. This one, right? I asked you to find fx when I give you something like this. Quite easy, right? Quite easy. So you can just set this one, right, to be 0. No, not 0, I'm sorry. You want to get fx, so you can assume this one to be a. You can assume it to be a, right? So you will have like fa equal something, right? And now your a is 5x plus 2, right? So your x, a minus 2 is 5x, so x is a minus 2 over 5. So you have to change now. On this side, like your x is going to be 10 times a minus 2 over 5, and then plus 7. Yep, when you do the math, 5 and 10, you get 2, right? 2 times a is 2a, 2 times negative 2 is negative 4. Negative 4 plus 7 is plus 3. So FA is 2a plus 3, and A is anything, right? A is anything. So if you want to change A to X, it's fine. You change A to X, so your FX is just 2x plus 3. Finish. Very easy, this problem. Sure. Okay, let's get next one. Composite functions, find F2. You have f of g and gx like this. Okay, let's do it. Let's start like f or g of x like this is f of gx. Right, f of gx is 10x plus 1. You already have your gx, right? So gx, so you write f of 5x minus 2, right? To substitute gx there. There, function gx, you know what? So it's 10x plus 2. And what do you want, right? You want to have f2. You want to have f2. So what do? You have to find a good value of x that makes this one equal to 2, right? And you will have f of 2. So let's find it. You want to change 5x minus 2 to be 2, right? So if you want to change 5x minus 2 to be 2, what should be your good x? What should be your good x? So 5x, it's going to be 4. So x is 4 over 5. That's your good x. That's your good x, right? So you put 4 over 5 in your 10x plus 2. Right? 10 and x is 4 over 5. And then plus 2. 2 times 4 is 8. 8 plus 2 is 10. So F2 is 10. Very easy. Finish down. You know, right? It's just very easy. You try to make it fast, okay? Because you have to save the time. Your time is very limited. Okay. Inverse. This one, right? I'm gonna ask you like which of them, like we have like many choices. Which of them has its inverse as a function? Okay. You know what I mean, right? Okay. If you still remember, let's say if I ask you like this. Let's say y is equal to x squared, right? Y is equal to x squared, right? I give you a function like y is equal to x squared. So this one in the graph, it looks like this. I draw like x and y axis. It's a parabola, looks like this, right? So change to inverse. If you change to inverse, right? If you still remember, we use that 45-degree lines. Shift. So this one, if you reflect with the 45 degrees, you know what? Remember the life hack. It's gonna look like this. If this is your f, this is your f inverse, right? And this one is say which of the following has its inverse as a function. You know, right? Y is equal to x squared. The inverse is like this. And is it a function or not? Function or not? We use the vertical check. Remember, like this. Rainfall. So it's not a function. This is not a function. You would say, right? F inverse is not function. Right? F inverse function because it doesn't pass the rainfall check or it doesn't pass the vertical check. So what does it mean? So you have to look for the choice that, you know, right? Let's say if this is like choice 1, You're not going to choose this one because your function, the parabola, which is like this. If you flip it 45 degree, symmetric axis 45 degree, right? When you find the inverse, it will come out like this, and then it doesn't pass the vertical check. So inverse is not a function. You're not gonna go for that. Let's say if I have like number 2, I have the opposite of this one. I say like x is equal to y squared. So you know it's gonna look like this, right? It's gonna be a parabola, but it's look like this. You're not gonna go for this too, because this one, the function is the original doesn't pass. This one, right? The original doesn't pass the vertical test. So it doesn't have the inverse because the original is not yet a function. The original is not a function, so it doesn't have the inverse. So you don't want to go for that. Okay, let's say number 3. I don't know. I just go random. Let's say I have y is equal to absolute x. Right? Okay, that is equal to absolute x. Y is equal to absolute x. It looks like a V like this, right? It looks like a V. It looks like a V. So a V, if you get it, this is F. If you find F inverse, right? It's gonna go along the 45 degree. You flip it. It looks like this. Again, error. It doesn't pass the vertical test. So this is not a function. You're not gonna go for this. So you know what I mean, right? But I have like 5 choices. So you have to think. You have to think. You have to think like which one is okay. You look in the book. Okay, I have some examples. I have some equations that I have taught you. So you go for this. You go for those things. So again, you're gonna have to think like what kind of graph that will come out. That when you go 45 degree, flip it 45 degrees, and it will come out to be a thing that passes the vertical test. Yeah, let's say if I have a linear, let's say linear function like this, or maybe have a parabola like this. Let's say I have a parabola like this. If I go find an inverse, right? This one, if I flip it, it's gonna look like this. Yeah, something like this is fine. You know, right? Let's say if this is like chart 4. Chart 4, you have a parabola like this. The parabola on the just on the positive side, and then this is your f. You find f inverse, right? Yeah, this one is fine, right? This is a function, pass the vertical test. When you find the inverse, reflect with 45 degree, it looks like this, and it also passes the vertical test like this. You know, right? So this problem, you have to go to read in a sheet and find the function that have, you know, right, this kind of properties. It's a function. The original is a function, and then the inverse is also a function like this. You have to go for that. You know, I would say like linear, or maybe like half circle, half a parabola or something. I don't know, half of something. Okay. Good luck. Let's go for the next one. Domain and range, easy. You know, right? You still remember? I taught you already. Domain of F, right? Domain of F is range of F inverse. You know, right? Because F and F inverse, they are always like opposite for domain and range. So domain of F inverse is gonna be the opposite of range. Range of F, yeah, it's gonna be equal to range of F. It's gonna be equal, you know, opposite, sorry. So let's find a domain of F. 2x minus 1 is in the root, right? You want to find a domain, so you have to go for like 2x minus 1. Must not be negative, like it mustn't be negative. So 2x is more than equal -1. X is more than or equal to -1/2. Yeah, so this is the domain, right? So domain of F, it's the same as range of F inverse. Then you go. negative 1 over 2, 0. Oh, no, not 0, infinity, like this. Yeah. Now, you want to find the domain of f inverse, right? Domain of f inverse. It's going to be the range of f, so you look for the range of this f, right? You know, right? If you set your domain to be if you set your domain to be more than or equal to negative 1 over 2, this one will come out to be positive, more than or equal to 0, right? So root of something that is more than or equal to 0 will come out to be minimum at 0 and maximum at infinity. Yeah, this one, something like this. Okay, so next one, let's find the inverse, right? Let's find the inverse. Okay, so easy. Let's find inverse. Okay, we're gonna spend fx, right? You change that fx to y and then square root of 2x minus 1. Square it out on both sides. No. I'm sorry. I need to swap first. If I want to get f inverse, I have to swap it. Swap x out, swap y in. Square it out on both sides. I have x squared equal to 2y minus 1. So my y alone is x squared plus 1 divided by 2. Okay. I'm very sorry. I'm kind of like sick. Okay, so that's it. Square root of 2x minus 1. Then your f inverse, it's gonna look like that. Right? X squared plus 1 divided by 2. Okay. Ship. Operation of functions. Okay, this topic, right? I don't have enough time to teach you in the class, but it's so easy. You know, right? It's so easy. It's so easy. If you have, let's say, f plus g of x, that is equal to f x plus gx. You know, right? Very easy. Same as minus, right? If you have f minus g like this x, so it's go for something like that. If you have f times gx, it's like fx, like this, multiply with gx. So easy. F over g, and then x is equal to fx divided by gx. But gx is not 0 because you don't want to divide it by 0. It's so easy, right? If you can work with functions, this is so easy. I think you already understand it. I just teach you now. You understand it already. So this one, I give you like this. I want you to find f plus g1, which is equal to like f1 plus g1. fg2 is f2 times g2. Very easy. F minus g3 is f of 3 minus g of 3. Very easy. So let's find f1 now, right? I taught you in the class already, like this one. If you want to get f, you go like this, right? You can just swap f inverse to the other side. So x is f inverse of x minus, oh no, not f inverse, I'm sorry. F of x minus 5 over 2, right? And then, easy. You want to get f1, right? I don't think that it's going to be okay for this one because you have multiple values. So let's find function fx. It's going to be easier. Okay, so this one, y is equal to that. You swap, right? You swap to x equal to y minus 5 over 2. You swap because you want to get f. I mean, not academic f, okay? you multiply this 2x is equal y minus 5. Okay. Wait a bit, okay? I need 1 minute, low bat. I need to charge this computer. Low bat, low bat. Okay, charge it. Charge it. Okay. Charge. Okay. Charge it. Okay, it's fine now. Has the battery. So it's gonna be fine. I'm back. Okay. Then y is 2x plus 5. So you know that your fx is 2x plus 5 now. It's 2x plus 5. Okay? So when you have fx, right? You want to find your gx, and you go here. F of gx is 10x plus 1. Right? F of gx is 10x plus 1. Okay. You want to get gx, so you go like this. Gx is f inverse of 10x plus 1. Right? I taught you that you can just move, like, if f is on the left, you move it to the right, it will become f inverse. If you have f inverse, you move it to the other side, it will become f like that. Very easy. Okay, so you want to get gx. Gx is f inverse of 10x plus 1. So you put this 10x plus 1 in that x and that x. Right? Okay, then you go. So f inverse is that x minus 5 over 2. Then you go 10. You put 10x plus 1 in this x. So it's gonna be 10x plus 1 minus 5 and divide by 2. So 10 divided by 2 is 5x. 1 minus 5 is minus 4. Minus 4 over 2 is minus 2. You have your gx now. Very easy. Then you go. Find this, right? Okay. F plus G1 is F1 plus G1. Then you go. F1 is 2 plus 5, 7. G1 is 5 minus 3. 5 minus 2 is 3. So F1 plus G1 is 7 plus 3. So this one is going to be equal to 7 plus 3. Okay, I write. F1 is 7. G1 is 3. F times G2. So you find F2 now. F2 is 2 times 2 is 4. 4 plus 5 is 9. And then G2 is 5 to 10. 10 minus 2 is 8. G2 is 8. So this one is going to be 9 times 8. Super easy. Right? Now you go F3. F3 is 6 plus 5. 6 plus 5 is 11. G3 is 15 minus 2 is 13. F minus G. So it's F minus G3 is 11 minus 13. Plus 11 minus 13. Sure. So that's a 10. This is 72. That is minus 2. So 80. Yeah, finish. Easy. Right? Okay. This is like fill in the blank now. I have 7 problem, 14 points. So you should do this one. You should do this one before the multiple choice because it has higher points. You know, right? But some problems here, some problem will be the same as, you know, use the same concept, same idea, like the multiple choice. So I will not show you all the 7 problems. Anyway, the concept is there. You don't see it, but the concept it is you. You see it in the class, in the exam room, and you can do it. Okay, so here it says like px is divided by x squared minus 4. So it's say px, right, is divided by x squared minus 4, resulting in a quotient. Quotient is like the result, you know, right? It's not there. It's not the remainder. So you divide it like this, and you get 2x plus 1. Remainder of x minus 2, it means this is like indivisible. So remainder x minus 2 divided by x squared minus 4. You know what? If you think of a number, let's say I want to divide 5 by 2. So I can divide it like 2 times, and I have the remainder of 1 over 2, something like this. So you break it into, you know, this is the quotient. Quotient is 2. Remainder is 1. And the divider is 2. Something like this, you know, right? This is called the quotient. This is called the remainder. And this is called the divider. Something like that. Easy. Right? So if you want to find px, you multiply this one to all of them, all the terms. So it's px, and then 2x plus 1 multiplied with x squared minus 4. This one, if you multiply, it's cancelled. Then you have like this. Very easy. You can do it by yourself now, maybe? Yeah, I don't have to do it for you now. Yeah, I think that you can do it by yourself now, right? Just multiplying. Yeah, the first to the third, the first to the fourth, the second to the third, the second to the fourth. Add them up. Try to simplify, and then add it to this one. You have something at here. Start with like 2x cubed, and then I don't know, like blah blah blah, and end with some constant. Okay, you do it by yourself. Okay, it's so easy. This is your answer. Fill in the blank. Okay, just write the answer. You don't need to show solution at here. Write in your scratch paper. Okay, and you just write your answer here, like 2x cubed, and then go on for it. Blah blah blah. I don't know. Save the time. Easy. Okay, let's go. How many integers are in the solutions of that? Oh, very easy, right? So you go 3x, right? You subtract all of them by 10. This is like negative 4, no, negative 30, right? Subtract 10 out, it's negative 15. And divide by 3, x is negative 10, and then negative 3. Very easy. Then you count for the integers. Count for the number, how many integers, right? So from negative 3, more than negative 10, but less than negative 3, then you go like negative 3, negative 4, negative 5, negative 6, 7, 8, 9, 10. You count 1, 2, 3, 4, 5, 6, 7, 8. Okay, have 8 numbers. Your answer is 8. Finish now. Right. Okay, page number 7. Oh, this one is very easy. I want to give one example of this one, right? Okay, if you still remember this, right? F A to B. A to B means, right? All A, but some B. All A, some B. It's something like this. If you still remember, this is like all A, and then some B. All A, some B. All A, some B. So you need to use all of them. So you need to have, right, minus 1 with, let's say, 4. You know what? All A, some B. B is repeatable. No problem. Maybe example is like negative 1, 4. Negative, no, negative 1. We write already 2. 2 with maybe 5. and then we can go 5 and back to 4 again, something like that. You know what? You can have different for me, okay? Because there are many examples of it. I just want one, the correct one, just one. That's correct. Number 2, right? B to C, and it must be 1 to 1. So you have to use all B, right? 1 to 1. 1 to 1, it means you have to use some of C, but C will never be repeated because you want it to be 1 to 1. Some C, but I would say C should not be repeated. Okay, just cross like that. Okay, so you go. You have to use all the B. So B 4, 5, 6. You may go like this: 4, 5, 6. Shup, shup, shup. You want it to be 1 to 1. So you don't want your C to be repeated. So maybe you can go for -5. You don't like -2. Okay, you don't like -6. Okay, so you can skip to 4, something like this. You see, right? I use all the B. I use some of C, and then my C, I don't have any like repeated members. Next one is on 2, right? On 2 means on 2 or is like on 2 means like all of them, all B, and then go to like all A, but right? On 2 means like that. All B, all A, like that. All B, all, no. This is C, right? I'm sorry, I have to use C like this. All C, all A, but A is repeatable. Fine, because this is not 1 to 1. It's not 1 to 1, so we can go all C, right? Okay, 5, -2, -6, like that. Okay, you may start -5, -2, -6, and then 4. Sure, like this, and then write all A. All A, you have to use all A. Repeat is fine. -1, 2, 5. Okay, maybe you can use like 5 again. Fine, no problem. You may have different answers for me. I don't mind because I want one different. I want just one correct example. One correct, you know, right? Correct. That it's okay according to this, right? Okay, the last one, like on 2 and 1, 1, right? This one means like you have to use all from B, and then you have to map it to all of A, and do not repeat A. Do not repeat A. So B, you have 4, 5, 6. You go 4, you go 5, and then you go 6. Chip. Goes to A. You can go with anything. Maybe I want to put 2 there. Maybe I want to put -1 there. Maybe I want to put 5 there. Right? I use all B. I use all A, and I don't have any repeating members of A. That's it. You know, right? Very easy. So this is like 1, 2, 3, 4. Maybe like 4 parts for you now. 4 parts. 4 parts. Easy. If you can do this one, you get 4 parts, right? But if you go for multiple choice, you have to make 8 multiple choice problem to get this one. So please do fill in the blank first. This is very easy. Oh, I think you know this one. F or G inverse? F or G inverse, right? F or G inverse of 1. Okay. So you have to find fx and gx again. Okay. If you want to get fx, okay, I think that you have to input x minus 1 there, right? Easy. Your x needs to be x minus. X needs to be replaced by x minus 1. You know what? And -1 and 1 will be like cancel. You know what I mean, right? Then you will get just fx. You find fx first, and then yeah, your x is now replaced by x minus 1, right? So fx is 2x minus 2 plus 7 plus 5. Finish now, right? And then you want to get dx, and you have to replace this, this x and that x by, I think, x plus 1, right? If you replace this x by x plus 1, right? Then plus 1 minus 1 will cancel like that. You will get your dx. Dx is it's going to be 5 times x plus 1 plus 7, 5x plus 12. Okay, finish now. First step, you want to find f or g inverse of 1, right? Then find g inverse, x inverse, okay? Find g inverse, x inverse, okay? I know, g inverse and f inverse. Okay, let's find it. You can swap it, very easy. Or maybe you know it. Maybe you know how to do this problem. Very easy. This is like y is equal to 2x plus 5, right? You want to get f inverse. So you swap it to something like x is equal to 2y minus 5 plus 5. So your y is x minus 5 over 2. Yeah, easy. X minus 5 over 2. And my minus is not okay. Minus 5 over 2. Finish now, like gx, a g inverse of x, you swap it. You swap it, right? You swap this. This is y equal to 5x minus 1. Swap x, y 2x, and x 2y. And you should get your y equal to x minus 12 divided by 5. Yeah, finish now. And then you go. This one, right? F or g inverse of 1 is f of g inverse of 1. Okay, g inverse, it's here. Put 1 there. 1 minus 12 is negative 11. Negative 11 over 5. Right? Negative 11 over 5. Sorry, not like this. It's f of negative 11 over 5. Okay. And you put negative 11 over 5 in your f. 2x plus 5. Sorry for bad numbers. So you will get negative 22 over 5, right? If you put this one in your x and then plus 5, it's gonna be 5 times 5, 25, 3. Yeah, 3 over 5. Okay. Yeah, you can do this one now, right? You want to get g of f inverse of 2. This is g of f inverse of 2. Very easy. Put number 2 in your f inverse, right? 2 minus 5 is minus 3. Minus 3 over 2. So it's going to be g of minus 3 over 2. And then you put this one in your g. You put this one in your g. Yeah. I think you know how to do it now. I think you know how to do this one now. Very easy. You know what? This one too, like maybe I'm gonna stop this one at here. It's so easy. You do it by yourself, okay? You know the steps now. Just put it there. Right? This one, right? This one is g inverse of f inverse of negative 1. So you go put negative 1 in your f inverse. Right? Negative 1 minus 5 is negative 6. Negative 6 over 2 is negative 3. So you will get like g inverse of negative 3. And you put this negative 3 there in your g inverse. Then negative 3 minus 12 is negative 15. Negative 15 over 5 is negative 3. You have finished, right? It's so easy. So this one, number 4, right? F over g plus f inverse of negative 2 is like this. F negative 2 divided by g of negative 2 plus the f inverse of 2. You know how to do this one, right? Negative 2 put in f. Negative 2 put in g. 2. Oh no, this is negative 2, right? Negative 2 put in f inverse. And then add what you have, divide what you have. You will get some number out. You can do it by yourself. I don't have to do it for you. It's easy. Right? Okay. Okay, last page now. Last page now. This one, right? Show the solutions. 3 problems, 6 parts. Here I have just 2 questions because again, it applies the same concept. So I have to. I don't have to do. I don't have to use. What should I say? I don't have to explain the same thing to you again. Like the same thing to you again. You have the concept. You can do it by yourself. Okay. So this one has 6 parts. So this is like you. This is like your second priority. You know, right? When you have your exam, you go for the fill in the blank, and then you come for this show solution part, and then when you're done, you go back to do the multiple choice. Okay, if the time is up, you can guess the multiple choice, but you cannot guess the solution. You cannot guess the blank. Okay, so you should do it like that. Okay, let's do this problem easy. Number 1, you want to find the answer. Do not cross multiply these inequalities, but you have to subtract them like this. X squared minus 2x minus 3 divided by x plus 3, subtract by 5. Okay, this is solution. You have to make it very clear to me, you know. I'm gonna be very, very stupid teacher, you know. If I don't understand something, I cut your point. You have to make it very, very clear to me. Ship. Okay, so you have to write it very, very like step by step. And negative 5 to x is negative 5x. Negative 5 to 3 is negative 15. You have to write very clear, very, very clear to me. Okay, so you go like x squared minus 7x, and then it's like 18 divided by x plus 3 less than equals 0. I think that is 9 and 2. So you go x, 9, x, 2. I'm going to get negative 7. So put negative to the bigger number, positive to the smaller number. And then less than equals 0 divided by x plus 3. This is the show solution part. So you have to write. You don't want it to be, you don't want to have x plus 3 below, right? So you need to multiply with x plus 3 square on both sides. Right? And then you need to put a condition that your x cannot be negative 3 because you don't want to divide this by 0. Right? Okay, maybe you put like this. X is not negative 3. When you multiply with the divider square on both sides, then you can just cancel like this. This one multiplying 0 is 0. And you have this x minus 9, x plus 2, x plus 3 less than equal to x to 0. And then x is not negative 3. Actually, you can just write it since the very, very first step, you know, right? X plus 3 is there. You don't want to divide by 0. Okay, then you go. 3 numbers, right? Start from the smallest, negative 3. This is 0, you get negative 2. Biggest one is 9, plus, minus, and then write the dot. This is less than or equal. You should use the close dot, right? Dark color. But anyway, x is not negative 3. So here you will leave it. You will leave it open dot. And then negative, right? You have to go for the no, less than, you go for the negative zone. Let's go for negative zone. Then I want to get the answers. The answer is x is from negative infinity to the open of 3 union with close of -2 to 9. That's it. Finish. Very easy. You get 2 parts already. If you can do like these steps, you get 2 parts already. Okay, number 2, right? Find F inverse. This is so easy. So easy, right? So easy. This is so easy. I just want to see you make it so clear, you know? Make it so clear. I just want to see your working step, right? So you want to find fx. Let's find fx first, right? If you want to find fx, maybe again, you let this one to be a. If you let it be a, you have fa is equal to something, right? Then you work on it here. Okay. Maybe you want to write, okay. If you want to go step by step, okay, let a, no. You should write on the left, right? Left, let a equal to 2x minus 1. Then change the sides. Add something, right? Change a plus 1 is 2x, so x is a plus 1 over 2. Sure, and you go. 2x plus 1 is a, so you have fa. And now your x is this a plus 1 over 2. 2 times a plus 1 divided by 2. Divide by 2 times a plus 1 divided by 2 plus 1. Like this. Chop. So you have a plus 1 over a plus 2. This is your fa. This is your fa. Right? I'm correct, right? Yeah, it should be correct. Okay. But now you want to get fx, so just replace your a back to x now. Fx is x plus 1 over x plus 2. Next step, find f inverse. Find f inverse. To find f inverse, right, you have to swap it. You have to swap it. Find f inverse, right? This is like y equal. This is like y, you know what? Y equal to something like that. You swap it to x is equal to y plus 1 over y plus 2. And you multiply xy plus 2x is y plus 1. And you go 2x minus 1 is y minus xy. Take the common factor of y out. You have 1 minus x like this, 2x minus 1. Then y is 2x minus 1 over 1 minus x. Then your f inverse of x is 2x minus 1 divided by 1 minus x. That's it. You get 2 parts from it. But there's another one, right? There's another one. So you have to work like quickly. Okay. So I wish you good luck. I'm gonna end my clip number 2 at here. I wish you good luck, okay? Which of you grade 4? Which of you grade 4, okay? Which of you grade 4? Good luck and have a good day, okay?